Okay, so if we're looking at systems of equations that we can solve using elimination, we're going to start with some simple examples here. So I have the system x plus y equals 7 and x minus y equals negative 1. Notice that here's a positive y and a negative y. If I were to add these together, then I would get 0. And this is always our goal in elimination. We want to add together the equations so that one of the variables is eliminated or is canceled out. The x's here don't eliminate, but of course we don't want to eliminate both at the same time. That only happens in strange cases. So and over here I add as well, so 7 plus negative 1 just gives me 6. As you get better, you might just write it as 2x equals 6, but that comes with a little more practice. If we consider the same systems of equation again, and now we want to solve for y, there are two different methods that you can do that. And the first one that I'm going to show you is a little more non-traditional. Notice the y's canceled out if I added, whereas the x are exactly the same. So if I subtract, my x's are going to cancel out and just leave me with 0. Now I have to be careful with my signs, but positive y minus a negative y is just like I had a 2y, and 7 minus a negative 1 is 8. So I could really just say 2y equals 8, so y equals 4. Now earlier I said that there was another method that you could use once you figured out that x is equal to 3, and that's just a method of substitution. So I could think of this equation, instead of it being x plus y equals 7, I can use my substitution for 3, and 3 can go in there for x. So I have 3 plus y equals 7, therefore y must equal 4. So that's another way to get the same answer there. If it works out this way, which is rarely the case, you could just do the opposite sign, so subtract. If not, you have to take the value that you solved for and substitute it into the original equation. So now let's consider this slightly more complex system of equations. Notice we still have the same thing here where y has a coefficient of negative 5. Always take the sign. Remember, always take that sign. So y is a coefficient of negative 5, and then here it has a coefficient of positive 5. So if I add those together, I'll cancel out and get 0. So I don't even need to write it. Notice I'll have 7x plus 0, but I'm not going to write that because it's just 0. Negative 28 plus 21 gives me negative 7, and now I see that x equals negative 1. We can't do the same trick as last time because if I subtract these, my x's won't cancel. Notice that 3 and 4 don't cancel each other out. So what I'll do instead is I'll do a substitution. And so I can start with either equation, and instead of writing x, since I know that x is equal to negative 1, I'll just do my substitution right away. So x equals, 3 times negative 1, and then the rest of the formula stays the same. The only thing that got changed was the x. So minus 5y equals negative 28. So I get negative 3 minus 5y equals negative 28. Negative 5y equals negative 25, adding 3 to both sides, and dividing both sides by negative 5 gives me that y actually just equals 5. So now I have x and I have y, and I'm finished. You might have wondered why I chose this first equation rather than the second one, and there's no reason. This equation would give me the same answer. Remember, these are lines, and we can interpret the solution as the intersection point of the line. The intersection point is negative 1 comma 5. So if I graph these lines, I'm going to see an intersection at this coordinate point, which means if I substitute this value into the first equation, it gives me a true answer. Same thing with the second. So let's see how we could use the second one to solve for y. Well, I'm going to have 4 times, and do my substitution for x, negative 1. And then I just finish, once again, the rest of the equation. 5y equals 21. Negative 4 plus 5y equals 21. 5y equals 25. And once again, y equals 5. So regardless of which one you chose, you'll get the same answer. And one final example here. Here you might notice if I add these together, it's not going to help me out. So if I tried to just add these two together, I'm going to get 8x and negative 2y equals negative 4. And obviously nothing canceled out. I haven't made it easier on myself, so that's not the solution that I'm looking for. In this situation, what I should have done was just a subtraction. Now it looks a little weird with all these negative signs, so let's start with the x's. 5x minus 3x just gives me a 2x. negative y minus a negative y actually becomes plus. And I'm not going to change this to plus because I don't want to get confused over here. But I know that this is just going to be a 0. 0 minus a negative 4 gives me positive 4. And I can see that x equals 2. From this point, I'm just going to do my substitution. So I like to start with whichever equation looks the easiest. And in this case, I think it's actually this one. So I'm going to have 5 times 2 and then minus y equals 0, or 10 minus y equals 0. That's only true if y equals 10. And now, as I said earlier, we have to think of this as two lines. This is line 1 up here, and this is line 2 down here. This point, 2 comma 10, is on both lines. And in order to kind of prove that to myself, I can check just to verify with the second equation if the point is on there. So I'm going to have 3 times 2 for my x value minus my y value of 10, and then I should get the answer of negative 4. And you probably see by now that, yes, I get the answer of negative 4. Therefore, this point is on both lines. It's the intersection for the two lines, and it's the solution to the system of equations.